Guided Conditional Functional Dependency Discovery. Conditional functional dependencies, CFDs, generalize functional dependencies and lend themselves to wide applicability. CFDs on data are usually unknown and too costly to be designed manually. To this end, CFD discovery methods are studied for discovering hidden CFDs from data. In the setting of data cleaning, only a small number of CFDs are used to detect and repair errors, while common CFD discovery methods find all CFDs, approximately, holding on data, and an expensive post-processing step is further required for selecting those relevant ones. In this paper, we present an approach to discover CFDs that can detect errors in data, guided by a small set of erroneous attribute values labeled by users. We present a method that consists of several modules of data sampling, CFD discovery and refinement guided by the user labeling and data resampling guided by the discovered CFDs, working in an iterative way. We present novel efficient techniques to facilitate our approach, aiming at identifying CFDs useful for cleaning and reducing user interactions. We conduct extensive experimental evaluations to verify our approach against the state-of-the-art CFD discovery algorithms with or without user interactions. Data quality management is one of the most important aspects of data management, and data cleaning methods e.g. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 are at the core of data quality management. Most of the data cleaning methods employ integrity constraints, dependencies, to state specifications that data should satisfy, and resolve violations by updating data to satisfy the constraints. To obtain the dependencies used in data cleaning and avoid the labor-intensive process of designing dependencies manually, approximate dependency discovery techniques are actively studied, e.g. 12, 13, for surveys, aiming at finding dependencies that, approximately, hold on data. Conditional functional dependencies, CFDs, 14, generalize functional dependencies, FDs. CFDs can express dependencies that hold only on a subset of data and are hence more applicable in practice and widely used in data cleaning tasks, 15, 16, 17. To find CFDs hidden in data, CFD discovery techniques 18, 19, 20, 21 are extensively studied. However, we find their limitations hinder them from efficiently finding CFDs useful for data cleaning. Traditional CFD discovery methods 18, 19, 21 discover all CFDs that approximately hold on data, which usually leads to a very large result set. Since data cleaning requires a small set of semantically meaningful CFDs, and usually only users can make judgment on the usefulness of CFDs, an additional post-processing step is needed for choosing relevant CFDs among all the discovered ones. This step is necessarily hard and tedious even by domain experts. An alternative is to involve user interactions at early states. Intuitively, this can help discover meaningful CFDs and also avoid the cost of discovering all CFDs, explain. 20 makes the first effort toward this. It asks users to manually identify and clean a set of dirty tuples only at the beginning, and then automatically discovers a single CFD that is assumed to explain all the user modifications. However, we argue it is very difficult for users to manually clean data, and even this is possible, it is almost impossible that all user cleaning behaviors are related to one CFD since users typically have no idea of the constraints underlying data. In this paper, we present a novel solution to CFD discovery, referred to as guided CFD discovery. Compared with existing works, our approach has the following advantages. A. Guided by a small number of user labeling, we identify a set of CFDs useful for data cleaning rather than a single CFD or all CFDs holding on data. B. We adopt the idea of active learning in user labeling. Users are asked to label erroneous attributes on a small set of tuples automatically selected by our system, instead of manually identifying and cleaning erroneous attribute values from all tuples. Contributions. 1. We propose a novel approach to CFD discovery, leveraging a small number of user labeling, section 4. We first sample a set of tuples, and users are asked to label tuples as being true or false, and label erroneous attributes on the false tuples. We then discover a set of CFDs concerning users' labeling and resample tuples by considering the discovered CFDs. Users are again asked to label the newly sampled tuples, and the set of discovered CFDs is refined based on users' new labeling. Our approach works in an iterative way until a set of CFDs that can detect errors is discovered. 2. We develop a set of techniques for sampling initial tuples, discovering CFDs concerning users' labeling, resampling tuples guided by the discovered CFDs, and refining or generating new CFDs according to users' labeling, section 5. Our aim is to find the CFDs that facilitate data cleaning and to help users label errors in a convenient way by minimizing the number of required labeling. Using both real-life and synthetic data, we conduct an experimental study to verify the effectiveness and efficiency of our approach against the state-of-the-art techniques for CFD discovery with or without user interactions, section 6. The results show that our approach can effectively discover a set of CFDs for detecting errors with limited user effort in labeling tuples.